All right, let's talk about overriding methods. So, one of the other cool things we can do with inheritance is that, remember, when I inherit from another class, I get all the methods and all the properties from the parent class. So it can save a lot of typing. But also sometimes I don't want what's in the base class. I want to make a change. All right, so let me kind of show you what's going on here. So we've got this class bird. All right, so in my app, there's a concept of a bird. A bird is a thing with a name. So I have the name, which is the property, and then the constructor. Okay, so when I make a new bird, it needs a name. And birds make sounds. Okay, so I have a make sound method. Okay, it's void, so it doesn't return anything. It just console logs the name of the bird, says, and then bird sound. All right, if I were to make a bird, so if I go ahead below, I'll just do it here actually. Let me comment all this good stuff out. Okay, if I make a new bird, okay, let new bird equals new bird, and I have to give it a name, because remember, the constructor takes a name. So this constructor here is these two parentheses. I need a name. So I'm going to, I don't know, call it Bob. Right, and then Bob can make a sound. So new bird dot make sound. Okay, because this is the make sound is any bird can make a sound. So I'm going to go ahead and run this npx ts node override hyphen method.ts. Okay, right, the Bob says. All right, it's a little silly, but you get the point, right? So birds have a method called make sound. Now, if I make a new interface, a new class, excuse me, so let's say I do like class, I don't know, penguin. Class penguin extends bird. All right, well, cool. Like, let's say I just did this, right? Like, I haven't done anything else inside the penguin class. Let's do a new penguin. There's Mortimer. Remember, everything's inherited, so the constructor is also inherited. So you will have a constructor like this, okay? So that you don't have to retype this. All right, let's run it. Oh, forgot to have Mortimer make a sound. Okay, you see how basically once I inherited from bird this extends, I got the constructor, I got the make sound. All right, so basically I didn't have to really type much or anything. It's just, use all the stuff from the parent class. So I'm going to use a fancy word now. Okay, make sound. Oh, let me get rid of this too. And this is fine TypeScript. This is the base implementation. Right? This bird class is the parent class. It has a function called make sound. This is the base implementation of make sound. Now, I might want to do something different. So, for example, each bird might make a slightly different sound. Like, all birds make sounds, but some birds make slightly different sounds than other birds, which is fine. I might want to override the base implementation. I may want the child class to do something a little bit different from the parent class. That's really easy. So we have the class dove, which extends bird, and it also has a make sound. Notice the spelling and everything's exactly the same, and so is the return type. All right, when I do dove, it will say something slightly different. Right, so let's go ahead and try this out. So I have some, and I did the same for some other ones. So for example, a dove will go coo, an eagle will go murica, okay, and then we'll deal with flamingos in a second. Let's just do eagles and doves. I got my eagle, I got my dove. Right, we're going to go ahead and console log this and run it. Right, the dove says coo and the eagle says murica. Right, so they both have a make sound function. So you see that this method here, make sound. I'm sorry, I'm trying to make sure I'm keeping method and function straight, but people mix it up all the time. Dove.make sound, eagle.make sound. Both these methods exist in the bird class, but you'll notice that in eagle and dove, I've overridden them. Okay, so this is an override. It says, sure, the base class did something, but I don't want to do what the base class does. I want to do my own thing, right? So instead, the eagle makes a different sound than the dove. So you can see why you would use an override when the child class does something slightly different than the base class. Now, does that mean that you, like, once you override the method, you totally lose the base class? No. Take Flamingo for example. We have Flamingo has a make sound, but here I do super.make sound. Super says, hey, go to the parent class, go to bird, and run the make sound method. Then do this. So let's go ahead and see what this does. Comment this stuff out, and then do my Flamingo. And comment this stuff out. All right, let's see what the Flamingo does. Okay, the Flamingo, okay, did on line 29, did the base implementation of make sound. Then it did this new thing that I added. So it went super make sound, super.make sound, went back to the bird class, it ran this code. Okay, and then after that, it did its own thing here. So you don't lose the base implementation. You can use super to basically say, okay, cool, go to the parent class and then run this thing. All right, so now the cool thing is that we have birds that do a bunch of different things. So they're all birds. Okay, they're all birds and they can all be treated like birds. But because we are using overriding methods, each bird can do a slightly different thing. So doves can go coo, eagles can go murica, and flamingos are very mean birds. They are awful, horrible devil birds. All right, so one more thing I want to show you. Now, you might be thinking, well, Jonathan, we have this bird, right? This bird class right here. But really, like, we never really deal with birds like this. We only deal with flamingos and doves and eagles, right? So, like, we have birds as a concept in our app, but we never really deal with birds as a concept. We're always dealing with a specific kind of bird. Okay, so what I'm going to say is we always deal with concrete birds. Okay, something concrete, meaning an actual bird like a crow or a hawk or something like that. There's this idea of bird, this abstract idea of what a bird is, a thing with wings that flies, okay? Like we have an idea generally what a bird is abstractly. But in our app, we don't really deal with the abstract concept of a bird. We deal with the real birds, like specific birds, like a crow or an eagle or a hawk. Okay, so try to see if you can understand this idea of we have an abstract idea of something, and then we have a concrete version of something. Now, what that means in programming is I probably don't want to let someone do what we're doing on line 36. Like, in my app, there are specific kinds of birds. There's no, like, bird idea. This might cause bugs in my program. But and currently as it stands, this program will run. Like, if I run it, everything will compile and run. Nothing's stopping me from doing this. So I have two options. I could say, like, hey, like, don't do this. Or we can make bird an abstract class. We use the abstract keyword. All right, and now, because bird is abstract, it cannot be instantiated. Okay, I'm going to repeat that. If you make a class abstract, it cannot be instantiated, the end. That means that line 36 is no longer valid. We must get rid of it. So now what that means is no one in my entire program can create a new bird. They have to pick one of my concrete birds, okay, well, a flamingo, an eagle, or a dove. They have to pick something that's concrete. They can't use just bird in the abstract. This is a very high level, like, concept. It may take a couple, like, listings of the video to try to grasp what I'm saying, okay, but once you make a class abstract, the new keyword is no longer applicable. I cannot do this. New bird, can't do it. Will not compile, do not pass code, do not collect $200. You are basically saying that I do not want this class to be instantiated ever. And you're like, well, Jonathan, what's the point of that? Like, we instantiate classes so that we can do work. That's what you've been telling us the past few videos. That's what we've been doing. Like, why would you make a class that you purposely do not want instantiated? Because it may be such that I only want people to deal with the concrete classes, right? Like, I want the bird to make a specific kind of sound or to call back to the parent class. It's sort of flow control, right? I'm telling other programmers that this has, like, a bunch of stuff that is useful for the other classes, but the other classes have to add their own special sauce to the mix before we could serve it to the customer. So it's like we everything has a certain functionality, but when we give it to the customer, when we want give it to the end user, we have to make certain that it's of a specific kind, like it's a dove or an eagle. Okay, very, very, very difficult to talk about like sometimes because like this is very, very abstract. Didn't mean to make a pun there, but this is like this concept is very like okay, well, like what do you mean? Like, why would you ever do this? For our class, you probably will never need to make an abstract class. I just want you to know this is a thing, that when you see this, by definition, this class can never be instantiated. And that's by design, because you don't want in your program to have just a bird by itself that isn't a particular type of bird. You just want to have this as a base class, and then other classes will extend the bird class, and then these are the classes you want other programmers to use inside your app. Okay, it's forcing other people to follow your pattern.